Here are some of your homework problems from section 8.4, page 449. We are drilling, practicing with these properties of logs that we talked about in class. So I hope this homework serves the purpose of helping you with practice have a better understanding of the product property, the quotient property, and the power property. So I just thought I'd do some of these for you, but obviously again use this as it's intended. Let this help you, but don't let it substitute for you doing it yourself and being able to successfully do these problems on your own, and in some cases multiple times, to be really good when it comes test time. So here's number 13. The instructions for this block of problems 11 through 18 says to write these as a single logarithm. Well, before I can combine multiple logs into a single log, I've got to move any numbers that are currently being multiplied. And we looked at that in class today. This is going to involve the power property. So I can take this 5, that's really a factor, it's being multiplied, and I can move it so that it becomes an exponent. All right, so I'm just going to rewrite this part. Okay, and now we can go ahead with our calculator, if you need your calculator, and find out what 3 to the 5th power is. That's 243. So instead of saying log 3 to the 5th, we can just say log 243. So that's the only difference between the second blue line, or the first blue line, and the second blue line. Okay, now I'm going to apply the product property, which says two separate logs of the same base that are being added can be joined together as a single log using multiplication of these numbers, 243 and 4. So once again, multiply 243 times 4 in your calculator and you get 972. So the answer to number 13 is log. Of course, we've talked about how that's an understood base 10 since there is no base showing. Log 972 is your answer for number 13. Okay, here's number 14. Once again, the first thing you should look for are these numbers that are being multiplied, because before you can combine separate logs, you basically need to clear out this space in front of the log. So the product property helps us with that. So 2 that's currently being multiplied will be moved to being an exponent for 6. Okay, just wanted to show you that. And then just one more little step here. 6 to the 2nd power, of course, is 36. Okay, and now we've got really two properties that are going to need to be used. And I would suggest that you just be very deliberate, and as you move from left to right, just take these logarithms 2 at a time. Notice that these two logs are being subtracted, so I have a property that says two different logs of the same base that are being subtracted can be put together as a single log using division. So here is the combination of these first two logs, and I'm just going to bring this other log 3 down. I haven't used it at all at this point. Okay, and if you can reduce, you should. Hopefully you can see that 8 over 36, you can divide 4 into both of these, and I'm just going to make it become 8 divided by 4 is 2, and 36 divided by 4 is 9. So I'm just going to make this become 2/9, just reducing. All right, and now two different logs of the same base that are being added can be combined together using multiplication. So I'm just going to show it like this. Log of 2/9 times 3. Okay, And if you multiply 2/9 times 3, that's 6/9, which reduces to 2/3. So my answer for number 14 will just be log, again it's base 10, log 2/3. Okay, let's try this one. Now we're jumping into the next set of problems, and the instructions have changed. Now we are expanding. And so it's kind of the reverse of what we were doing before. Now I need to pay attention to where operations, multiplication, and division are taking place. And I'm just going to note that I really have 4 different terms here. The number 22 and the variables x, y, and z represent basically 4 different terms, and they're each being multiplied together. So at each place where I see multiplication, I'm going to think of that as an expansion place. So you can also think of it this way: since there are 4 different numbers being multiplied together, that means I'm going to expand using 4 different log base 7s. So it looks like this. I'm going to do log base 7, 22, plus, so now, again, where we see multiplication, that tells us we're going to expand with addition. So my next part of the expansion will be log base 7x plus log base 7y plus log base 7z. So I guess the most common made mistake when students are expanding is not seeing that these are separate terms that are being multiplied together. So I'll see a lot of something like this. Maybe they just do log base 7, 22 plus x, y, z or something like that. But wherever multiplication happens, we need a separate log being added. Okay, we're going to separate these terms out with their own personal log of whatever base is in the problem. Okay, so let's try number 21, because sometimes these radicals can cause trouble, and I gave you a very important tip in class today that said you need to always change radicals to their rational exponent form. Okay, so I did 2 things here from the red. I indicated where multiplication is because that's where I'm expanding with plus another log base 4. So I'm going to have 2 log base 4s in my expansion. And I also changed the square root of x to the 1/2 power because when you're expanding, you will not have exponents. So we're going to do the power property, but in reverse of what we did previously. Exponents need to be brought down and used as factors. So just keep in mind when you're expanding into multiple logs, you always want to move exponents down so that they become factors. So your answer is going to look like this. Log base 4 of 5. We're expanding with addition since we're multiplying, plus, and now remember, exponents are going to be brought down and used as multipliers. And that should be your answer for number 21. Okay, log base 4 of 5 plus 1/2 log base 4x. But the key is always change radicals to rational exponent. Okay, here's number 22. Same instructions. We are expanding. So once again, I'm just going to emphasize where the operation multiplication is taking place. So this tells me that when I'm done, I should have 3 different log expressions being added together. All right, and I've also got to deal with the power property because in your expansion you should not have any exponents. So it's going to look like this, log 3. I think I'll just step this out one property at a time. Here's the product property, plus log m to the 4th, plus log n to the negative 2. Okay, that's an application of the product property, so you can see it. Now I'm going to do what I said earlier and make exponents become factors, and this is the power property. Log 3 plus 4 log m. Now I'm bringing down minus 2, so you could do plus negative 2, but I'm just going to show it as minus 2 log n. And this is an application of the power property. And that should be your answer for number 22. All right. So far so good. Hopefully you're understanding this pretty well. Let's try number 24. What I would do in problems like this that involve parentheses and everything in the parentheses being raised to a power, I think it's a little bit easier to think about this as each of these numbers in the parentheses being raised to the power. And obviously, the operation between them is multiply. Okay, so I'm going to use, again, I'm going to use the power property. And I'm just going to show them one at a time. So log base 3 of 2 squared, which is, just go ahead and show that, plus log base 3 of x squared. Now, the whole idea here is to expand, and so you really don't want to treat this as 4. You want to go ahead and apply the power property, which says 2 times log base 3 of 2 plus 2 times log base 3 of x. Okay, so I know you're tempted here to say log base 3 of 4, but the goal here is to basically practice these properties, put them into practice, and so you want to treat these exponents as you're expanding as factors. All right, so that should be your answer for number 24. All right, here's number 27, and once again I have a radical, so I'm just going to show this in, first of all, instead of everything under a square root, I'm just going to show it as everything being raised to the 1/2 power. Okay. Now, here's what it looks like without parentheses. Everything being raised to the 1/2. 2 to the 1/2, x to the 1/2 over y to the 1/2. And I'm going to indicate multiplication right here because that's where I need to expand using 2 different logs and multiplication. So once again, I think I'm going to do my properties separately. I'm not saying you have to do this if you're starting to get the idea, but I think I'm just going to slow it down a little bit and show you, first of all, an application of the product property. Okay, log, of course it's base 10, 2.5, plus log x to the 1/2, and then I see division, and I expand wherever division is using subtraction, log y to the 1/2. Okay, that is both the product property in the numerator and the quotient property to take care of this division. Now I'm going to do my power property because, again, when you expand you will not have any exponents, so these exponents come down and multiply. So 1/2 log 2 plus 1/2 log x minus 1/2 log y. You could have combined those two, all the properties together, and that's fine, but I just want to make sure everybody understands. You can get a clear picture of these properties as they're being used one at a time. So that is your answer for number 27. Okay, let's try another one. This is number 29 in that same block. We're still expanding, spending a little bit more time on expanding because that seems to give people more trouble. This is an S. Here's multiplication. Here's a radical, so I'm going to change it. And I'm going to make it 7 to the 1/2 power over t squared. So at this multiplication, I'm going to expand into two different logs in addition. Okay, so log S plus log 7 to the 1/2 power. And now where there's division, again, I'm going to expand using subtraction, log t squared. Now, let's do the power property and move these exponents down as multipliers. Log S plus 1/2 log 7 minus 2 log t. Okay, and that should be your answer for number 29. So far, so good. Having to use these properties will be very important. Now, let me do, I think I've got a couple in this last section, and I want you to pay close attention to what you're being asked to do here. The directions say to, first of all, use the properties. So I do want you to show these properties in use. Even though you might see a different way of getting the answer, that's not the issue here. I want you to have to use the properties, and here's what I mean by that. I'm going to use, first of all, the power property to move this 5. I'm essentially trying to combine these two logs into a single log. That's what you're trying to, that's your thought process on all these problems, 33 to 41. Make these multiple logs become a single logarithm, and then I'll show you what to do from there. So again, two logs. First of all, I can't combine these until I move this 5 so that it's an exponent. Okay, and now it's okay if you want to call 3 to the 5th 243. Okay, let's double check that. 3 to the 5th, I think we had that before. Yeah. Okay, so all right, and now I want you to show the product property, which says two separate logs being added can be put together as a single log using multiplication. So I'm going to show this. Okay, not that you have to. And so really, as a single log, this would be log base 3 of 729. Okay. Now, what we're trying to do now is evaluate, and now it goes back to yesterday's lesson. Now that we're down to a single log, let's think about what this is in exponent form. Remember, evaluating a logarithm essentially means what is the required exponent. In this case, to take 3 as our base, raise it to some power in order to get 729. That's what evaluating a log is. It means find the required exponent. So again, you can use your calculator, and if you need it, but using your calculator, you should find out that the exponent required 3 to the 6th power is 729. Okay, now that's using the properties, and I do want you to have to go through, again, drill and practice the properties. But let's get to our answer much quicker. If you evaluate log base 3 of 3, hopefully you see that that's just 1. Okay. Now here's something else that we'll talk about more in depth. Whenever you have this situation of log base 3 of that same number raised to a power. Okay, I'll do it like this. If you have log base b of the same number b raised to the x, evaluating that log, it's always just whatever the exponent is. Okay, here's another one. Log base 8 of 8 to the 7th is 7. Okay, so you'll know going forward, those are easy to evaluate. Well, if we apply that same rule to this, log base 3 of 3 to the 5th is just 5, and 1 plus 5 is 6. Yeah, that's what you will be able to do later, but for today, I want you to purposely go through the properties. Okay, and I'm going to do one more. All right, so using our properties, our goal is to combine two different logs into a single log expression. The first thing I'm going to do is get these numbers 2 and 1/3 out of the way so that I can combine these two different logs. All right, and let's take care of these exponents. This is log base 8 of 16, and this is log base 8. Now, I know I told you earlier that you could just call this 1/3, but what is 8 to the 1/3 power? Well, that's another way of saying the cube root of 8, which is 2. Okay. Now, again, I want you to use the properties. So, two different logs of the same base that are being subtracted can be joined together using division of those numbers. So this is really log base 8 of 8, which gets us to our final answer. We're supposed to evaluate, and this simply means 8 raised to what power would equal 8, and that power that we're looking for is 1. All right, I think that's all I've got, but I did several, maybe 11 or so of your problems. So I hope that helps you out on your homework, but if not, you're always welcome to come and see me during academic support.